Good morning, students. Today we are going to see the subject network theory. So, under topic is transient response. Myself, Dr. G.S. Satheesh Kumar, assistant professor. Myself, Erode Sengunthar Engineering College. Okay, right. So now today we are going to see the important topic in network theory that is called transient. Let's go to the topic. So, what is transient? So, simply we can tell it as sudden changes in a circuit. We can call it as a transient. The simple sudden changes in a circuit we can call it as a transient. Okay, so one more important point, the transient will occur only the circuit having a energy storage elements like inductor and capacitor. If we have a pure electrical network, that is it contains only the resistance, means it will not have any transient in the circuit. Okay, so that's why for a theorem, for example, network theorems, so many theorems we are studying. Okay, so some of the theorems we are dealing only with the resistance, not for inductor and capacitor. And okay, so next important topic in network theory, that is called transient response. So we need to analyze how the circuit will be respond based on the sudden changes in the input. Okay, so generally how the circuit will behave means, have to behave means, if we are changing the input in sudden, the circuit will be response in a same way. Okay, now, so how quick the circuit will be response, that is called transient response. So generally the circuit will be response so quick based on the input we are giving. So that is that circuit we can, that one is the very good circuit we can tell. Okay, so we are analyzing how the transient will occur in the circuit, and how, what is the behavior of the transient in a circuit. So under the transient condition, how the electrical elements like inductor and capacitor will be behave, and how to find out the transient response of the particular given circuit. Like here we are going to discuss about series RL circuit, or how, what is the transient condition of the series RLC circuit, that and all we are going to see in this topic. Okay, so what is transient? So transient occurs in the response due to sudden changes in the source that are applied to the electrical circuit due to the switching action. So switching action means, so we are suddenly giving input to the circuit, closing the switch. Now suddenly we are removing this supply from the circuit to the circuit by opening the switch. So mainly the transient will causes in the two cases. One is sudden opening of the switch and sudden closing of the switch. Okay, so based on this sudden changes, how the inductor and capacitor will be behave, how, and also how, what is the behavior of the circuit on the particular transient condition. So that we are going to see. Okay, so the transient part occurs in the response of the electrical circuit or network due to presence of energy storing elements such as inductor and capacitor. Why we are only discussing about inductor and capacitor, not for a resistance? So resistance will not changing any, will not storing any energy. Just it will giving what all the input we are giving, that is taking as an output. It will not storing any energy, and also it is easy to respond based on the inductor, based on the input voltage and input current. It suddenly responds. But the inductor and capacitor both are what work based on the time, how time it will based on the time. So we are analyzing the inductor and capacitor, how it will behave at the condition of transient. Okay, so in a, generally we are speaking a transient circuit. So we have two levels of two parts in a transient. So two parts in a transient, so that is transient response and steady state response. The circuit will be behave in two way, that is transient response and steady state response. Okay, so in a steady state response, the sudden change after we are giving input, sudden changes will be occur. It will take some time to attain steady state position, that also original position, original condition. So that is steady state response. So we have classifying this transient response into two. One is time response into two. One is transient response, another one is steady state response. Why this transient response? Because the transient will be based on the time how much time it will take. It is mainly based on the time. If the time will be increasing, the transient response will be also increasing. The transient response will be mostly zero. If it will take more time to time means the transient response will be totally maybe it will zero. Okay, so time is mainly depends upon this response. So that way that it is called time response. In the time response, we are taking transient response and steady state response too. Okay, so what is transient response? After applying an input to the electrical circuit, the output takes certain time to reach the steady state, right? So the output will be transient state till it goes to the steady state. So it will vary based on the input. Maybe it will increase or decrease. It will get some oscillation, and it will attain the original steady level. Therefore, the response of the electrical circuit during the transient state is not so. It is known as transient response. After you are giving the input, it will take some time. It will change somehow. It will change their original input to some other values based on the depends upon the sudden input changes, and will respond. That is called as a transient response. Maybe the transient response will be zero for large value of t. If the time value is getting increased, the transient will be zero. Okay. Ideally, this value of t should be infinite, but practically five time constants are sufficient for analyzing. Okay. What is the presence or absence of transient? The transient occur in a response due to sudden changes in the source that are applied to the electrical circuit or due to switching action. There are two possible switching actions we first discussed, that is opening of the switch and another is a closing of a switch. Okay. So transient part will not present the response of an electrical circuit or a network if it contains only the resistance, because the resistance have its ability to adjust any amount of voltage and current it changes with respect to time. So resistance have the capability to change their response based on the sudden voltage and current changes. But the transient part occurs in the response of an electrical circuit or network due to the presence of energy storing elements such as inductor and capacitor, because they can't change the energy storage in this element instantaneously. So inductor and capacitor will not change their storing process in the instantaneously. Storing the energy storage in an instantaneous process. So it will take some time to respond. That is called as transient response. Okay. So now so the transient response mainly depends upon the inductor and capacitor we studied and high and how. Now we are analyzing how the inductor and capacitor will behave in a transient condition. Okay. Assume the switching action takes place t equal to 0. That means the constant switching. The inductor current does not change instantaneously when the switching action takes place. That means the value of the inductor just after the switching action will be same as that of the just before the switching action. So generally, the inductor will not respond sudden response of the change. So if suddenly I switch closing the switch or opening the switch, the value, the current in the inductor will not change. That will be both are same for after switching or before switching. Both are same. It will not change. So it is mentioned IL 0 positive and IL 0 negative. So both are same. So what it means is that after switching switches will be opening or closing, the current in the inductor will be, there is no change. It is a constant. Though same way the capacitor voltage does not changes instantaneously, similar to the inductor current. So in an inductor the current will not change instantaneously. For a capacitor the voltage will not change in instantaneously. So after switching the after opening the switch and after before closing the switch, both the condition the voltage in the capacitor will be the same. That is where that where this that is a condition of the capacitor. So if the switch is t equal to 0 or switch t equal to 1, that at the sudden changes the voltage in the capacitor both will be same value only for a particular time. Okay. So what is the steady state response? The part of the time response that remains even after the transient response has become 0. So transient response totally will become 0. After that, it will take some time to attain the steady state. That is called a steady state response. This means there won't be any transient part in the response due to steady state during steady state. So during steady state condition, transient condition, there will be a in a steady state condition there will be no any transient part. That means variating part. Okay. So how the inductor will behave in a normal condition? So if the inductor independent source is connected to the electric circuit or network having one or more inductor and resistor for a long time, then that electric circuit or network is going to be a steady state. Therefore, the energy stored in the inductor of the electric circuit is a maximum constant. Simply, if you are giving a supply, constant supply to the inductor, what how the inductor will behave? Inductor will produce in the constant current at maximum current in a constant level. For example, the inductor will produce in the 5 amps current means if you are giving input voltage, it will providing that 5 amps current for a constant period. So that is we are telling the inductor will behave inductor behavior. So if you are providing the constant supply to the inductor, it will provide the constant output in maximum constant output. Clear? Okay. So and the condition, therefore, the inductor will act as a constant current source in a steady state. So generally, in a steady state, that means generally in a circuit, the inductor will behave as a constant current source in a steady state. So the current source, constant current source, the current will be maximum. What will be the condition of the voltage? The voltage will be zero. So the voltage across the inductor will be VL equal to IL dL by dt. That is equal to zero because so in this condition, the inductor will behave as a short circuit in a steady state. Okay, so short circuit in a steady state, so current will be maximum and voltage will be a zero. So in this what point we are getting, so inductor will behave as a constant current source in a steady state condition. Okay, next, for a capacitor, if the independent source is connected to the electric circuit or network, so same way we are giving constant voltage to the capacitor, constant voltage to the capacitors, or maybe one or capacitor, two capacitor, three or capacitors are connected in parallel. Okay, we are giving supply to the capacitor. Okay, so what will happen, the capacitor will store the energy in a form of voltage. Okay, it is storing. So what it will provide, it will provide a constant voltage, maximum voltage at constant level. So it will provide, so inductor will providing the maximum current and constant level, capacitor will providing the maximum voltage and it is constant. So therefore the capacitor act as a constant voltage source in a steady state. Therefore the capacitor act as a constant voltage source in a steady state. So what is the current? So IC equal to C into dVc by dt. The current will be zero. So if in a circuit the current will be zero, what is the condition of the circuit? It will be a open circuit. So the capacitor as act as a open circuit in a steady state. So capacitor will act as a open circuit in a steady state, right? Okay. So capacitor will be act as a steady state, right? Capacitor will act as a open circuit in a steady. Okay, right. So next, now we are analyzing, finding the response of a series RLC circuit. How the response of the RL circuit. Consider the following series RL circuit diagram. The above circuit, the switch was kept open up to t equal to 0 and it was closed to t equal to 0. So, the DC voltage source having V voltage is not connected to the series RL circuit up to this instant. Therefore, there is no initial current flowing through the inductor. So, this initial condition, so t is equal to position is 0. So, resistance, inductor and voltage both are connected, both are connected in series. Okay, this is a series circuit, the switch is open, so there is no current flowing through the circuit. So therefore there is no initial current flowing through the inductor. Okay, so okay, so next in the circuit diagram we are closing the switch t equal to position 1. When the switch is closed to position shown in the figure, so this is a closed circuit, so current will be flowing through the resistance, inductor and voltage source. Now we are applying Kirchhoff's voltage law. So now the current I is flowing in the entire circuit since the DC voltage source having voltage in the connected to the series RLC circuit. Now applying KVL around the loop, applying KVL, so Kirchhoff's voltage law. What is the Kirchhoff's voltage law? Sum of potential rise, that is equal to sum of potential drop. Right. Now applying KVL around the loop, V equal to R I plus L dI by dt. So It is a sum of potential rise. So RL, potential drop across the inductor and potential drop across the inductor. It is a basic equation. So now we are simply rearranging. So di by dt, that is equal to R by L I into V by L. We are getting equation 1. The above equation is in the form of first order differential equation dy by dt plus py, that is equal to q. So now we are comparing what is q, q equal to v by L. So what is I equal to y. So what is p, so p equal to RL by y here, right? So x equal to t, y equal to I, p equal to R by L, and q equal to v by L. Now we are integrating. So the solution of equation 1, we are substituting, and where k is constant, so we are taking k equal to constant. Now substituting the value of x, y, p, and q in equation 3, in this differential equation, you will get one equation that is called I equal to v by r plus k e power minus r l by t. So here we don't know the value of k, so here we need to find out the constant value k. For that, we need to find out the k value. What we do, so here we are taking this equation. From that we need to find out the value of k. So here we know that there's no initial current, so t equal to 0 and I equal to 0 we are considering. So in this condition, t equal to 0, I equal to 0, substituting in equation 4, so I equal to 0 and t will be also 0. So if the t will be 0, the entire term of the e power 0, entire term will be 0 1. So k equal to 1. So here I equal to 0, so v by r. So from that k equal to minus v by r, we are find out the constant value. Now we are substituting this constant value in the equation 4. We can get one value that is I equal to minus v by r e power minus r by L of t plus v by r. It is an equation. Okay. So in this equation we have two terms. So this first term is, we can call it as a transient response, and this v by r, that is equal to steady state response, because the transient response depends e power minus this first, or that the first term we can call it as a transient response, and second term we can call it as a steady state response. So the response of series RLC circuit when it is excited by constant DC source, the first term minus v by r e power minus r by L of t, that is equal to transient response, and second term v by r correspond with, it is called as a steady state response. These two response are, now we are drawing this, what is transient response. So this is called transient response, and it is also called as a steady state response. So we discussed about the transient response. For example, the time equal to 0, the circuit will be open. Suddenly we are closing the circuit, the current will be gradually increasing at its maximum level. After some certain period, it will be retaining the steady state response. So this is the graph for RL series circuit. We can rewrite the equation I equal to v by r 1 minus e power minus r by L of t. We are getting the equation. Okay. So this is, we are analyzing how the transient will be occur in series RLC circuit. In the same way, we are going to, we can going to analyze the, in a few previous classes we are analyzing series RC, RLC, as well as parallel RL, RC, and RLC circuits for an analyze transient response. Okay, thank you. Next class we will see the series and parallel response of RC, RLC, and all. Thank you.